Okay. So the topic that we are going to study today is the types of measuring input. Why do we call it as measuring input? I hope you understand, because we are learning the basics of measuring instruments. So what are the measuring inputs that come into the instrument? That is the thing that we are going to study today. So we basically classify inputs, static input I am saying, not about dynamic input. Dynamic input will vary based on the frequency. What I'm saying here is it is all about static input. So the types of inputs are classified into three categories. One is desired, another is interfering, third one is modifying. Okay. So if we want to take desired input, I'll just take an example for you. I'll just take an example. What do you mean by desired input? If I want to define desired input is an input, or you can say a signal. One second. One second. Yeah. Desired input is an input or a signal for which you design your instrument. You want to measure that quantity only for which you design your instrument, or you want your instrument to get that reading. Such kind of inputs are called as desired input. For which you design your instrument are called as desired input. So the signal for which you design your instruments are called as desired input. Okay. So suppose I take an example. I've just drawn a manometer to make the thing simple for you. I'm just taking an example of a, I'll just change the color because I've got the feedback, sir, if you can change the color. So I'll just take an example of a manometer. Okay. Now you know what is the function of a manometer. I hope everyone knows the function of a manometer. I don't have to explain it again and again. Since we need to complete the syllabus, we will just go in brief about this topic. So the function of manometer is to measure the pressure. It is used for pressure measurement. Okay. We have used this manometer in Venturi meter and even in orifice meter, even in nozzle tube. Okay. All this plates, all these places we use manometer. It is used in pipe. Okay. In configuration with Venturi meter, we also use a manometer. So manometer is basically used to measure the pressure. Okay. Now we can see there are two outlets. Right now there are two outlets. Suppose this is the first position and this is the second position. We can see there are two outlets. Let the pressure coming from this side into the manometer be P1 and the pressure coming from this side from the manometer be P2. Now suppose both the sides, the section 1 is exposed to atmospheric pressure. Okay. And even the section 2 is exposed to atmospheric pressure. I hope everyone is understanding. Okay. Both the sides of the manometer are exposed to atmospheric pressure, and we also know that manometer also has a liquid. Okay. We fill this manometer with a liquid. Most preferably the liquid that is used is mercury. So suppose there is mercury filled within this manometer. If the pressure from both the side is equal, the level of this liquid, the level of the mercury in this manometer column will be equal. Okay, so suppose since the pressure from both the sides is equal, we know, suppose if this much amount of manometer liquid is there, which is mercury, we know that both the side will have the same level since the pressure on both the sides is equal. I hope you're getting. Okay. What I have tried to draw is I have tried to show you that since what I'm saying, since P1 is equal to P2, we know that the height in the manometer column will be equal to what? 0. And if height in the manometer column is equal to 0, and if I want to measure the difference in pressure, I know that P1 minus P2, since the pressure is equal, we already know that P1 minus P2 will be equal to 0. And we can even know it by this formula where we use that delta P, change in pressure is equal to rho into G into H. Now we know that rho for us into consideration, it might be for fluid. Suppose there is a fluid flowing inside. Okay. From this side, fluid might be anything. It might be an air, it might be a liquid, it can be anything. It might be a water, it might be an air. So we know that rho into G, both are constant. H is equal to what? 0. So what we will get is delta P will be equal to what? 0. Simple. Okay. Okay. So I hope you understood what was the function of this manometer. The function of the manometer was to measure the pressure difference. Now, since the pressure is equal on both the sides, the manometer will show zero height difference. If it is showing zero height difference, that means that the pressure is, the difference in pressure that is acting on this surface or on this manometer is equal to what? Zero. Okay, since it is related to atmospheric pressure. Atmospheric pressure is considered to be, I hope you know all this thing. Atmospheric pressure is considered to be zero when we consider it with respect to, I hope everyone knows, when we consider it with respect to this, what do we say? Manometer pressure, na? One minute. Atmospheric pressure is considered to be zero when we consider it with respect to, I forgot that word. Can anyone let me remind? What do we call it as? Atmospheric pressure is considered to be zero when we consider it with reference to, anyone? Can anyone reply to me? Atmospheric pressure is 1 bar. But when do we consider it to be equal to zero? When we consider it, no, it is called as gauge pressure, not manometer. The gauge pressure, if we consider it to be a gauge, okay, so the gauge pressure, even though atmospheric pressure is equal to 1, when we consider in terms of gauge pressure, it is termed to be equal to 0. I hope you understand. Okay, so the manometer, even though there will be pressure, P1 is equal to P2 and it is equal to 1 atmosphere, but when it comes to gauge pressure, gauge is nothing but a measuring instrument. Gauge is nothing but a measuring instrument. When we consider this pressure in terms of measuring instrument, we consider that atmospheric pressure, which is equal to 1 bar from both the side, is equal to 0. That's why we are getting P1 minus P2. We already know this. This is equal to 1. This is equal to 1. But since P1 is equal to P2, P1 is equal to P2. Okay, so even though there is pressure on both the sides, the instrument will read as 0. Why will it read it as 0? Because this is nothing but, this is measured in terms of gauge pressure. Now we will go back to the definition. What was the definition of desired input? One second. What was the definition of desired input? The signal for which you design your instrument, is called as desired input. Okay, so now we already know, here we were asked to measure the pressure difference. Okay, we were asked to measure pressure difference, and what is it actually measuring? It is only measuring pressure difference only. It is not having any other input except the pressure difference. Okay, so this kind of setup where we are only getting the input for which the instrument was designed, such kind of system is called as, such kind of system or such kind of input is called as desired input, where we are not getting any other kind of pressure. Okay, I hope you understood. I tried to explain you all the basics of this pressure measurement also. Okay, now we will take another example. This is also a manometer. Okay, one side of the manometer is, you can see it is supported to a system or it is fixed to a system. Another side you can see, where is my, yeah, another side you can see this is exposed to atmospheric pressure. Okay, okay, now suppose if this pressure, system pressure is greater than atmospheric pressure. Okay, system pressure is greater than atmospheric pressure, what will happen? Automatically the liquid column in this will fall down due to the high pressure, and the liquid column in this mercury column, what I'm saying, the mercury column from this side will rise. Okay, the level of mercury from the left, this is my left side. Okay, this is my right side. Since the pressure in the system is more than the atmospheric pressure, what is going to happen? We can see that the pressure in the left side automatically will rise because there is more pressure this side. So it will try to suppress the mercury from this side. It will try to suppress the mercury. So we will see that the mercury level here is down and the mercury level here is high. Now, if we try to find its difference, this difference is called as, suppose karo, this difference is called as H. Now let this pressure be called as P1 and the pressure in the system be called as P2. Okay, now we know that P1 minus P2, since we already know, okay, P1 minus P2 or P2 minus P1, whatever you want to say. Okay, whatever you want to say, since P2 is greater than P1, what we will write is P2 minus P1 you can write, or you can even write P1 minus P2, or you can even write delta P. It will automatically consider based on the sign that it will get from the output. So we know that delta P is equal to rho into G into H. Okay. Now we know that rho will be equal to what? Rho of this mercury, right? Rho will be equal to what? Rho of this mercury. So we assume this rho of the mercury, density of the mercury to be rho m. So this will be rho m into G into H. Okay, this will be equal to delta P. I hope you're getting now. Now, one more thing that I like to add here is, now we know that delta P is what? This H is what? This is my output, right? And delta P is what? If you can see, delta EP is what? My input, right? There is something which is called as output and there is something which is called as input, right? So what I'll get from here is delta P, or I can write output upon input. If I want to write output upon input, output is what? H, input is what? Delta P, right? So output upon input, if I try to take output upon input, what I'll get is output upon input. So I have to put this side delta P here. I have to put it in denominator. So what I'll get from here is, I have to put this side on this value. I hope you're getting this. This value should be put on the left hand side. So what I'll get is output upon input is equal to rho m into G. I hope you're getting. I hope everyone is getting what I'm trying to explain. So what I've got from this expression is output upon input is equal to 1 upon rho m into G. Now just look at this value. We know that output is what? Delta H. Okay? Or H, you can say input is what? P1 and P2. We already know the value of P1 and P2. Okay? So now what we are going to say, what we are actually seeing is output upon input depends upon a value. Okay? Now I would like you people to get unmuted for a second and I would like to hear from you. I am just telling you output, you know, output is equal to H, input is already known. So if I want to find H, suppose I am not having this manometer. Suppose I am not having this manometer, I am unable to read the manometer reading and I want to know, actually I want to know what is the value of H without using manometer. So can I, if I know P1 minus P2, since I already know what is the pressure, atmospheric pressure, whatever might be the input, P2 minus P1 or P1 minus P2, it doesn't matter to me. I will always consider the positive part of it. So P1 minus P2 or P2 minus P1, okay? If I am considering P1 minus P2, if it is coming out to be negative, my H will automatically be negative. Okay? If P2 minus P1 is positive, I will automatically consider my H to be positive. Okay, so what I am saying, if I don't know, if I have not used this instrument, one second. If I have not used this instrument and if I don't know, if I'm not able to measure this H, I would like to know if I want to measure H, if I know P1, if I know P2, can this side be known or unknown, right hand side? Can I know this value or not? Anyone? Do I know the value of mercury density? Anyone? Hello? Hello? Do I know the value of the density, mercury density? What I'm asking, if I want to measure H without using manometer, can I find it? Anyone? Put it in the, use your voice. Okay, Tabish is saying I can't find H without knowing the value. If I am not having manometer, I will not be able to find H. Is it true? Anyone else? I know the density. Bilal has responded that I know the density. So what I am saying, if I know H, if I know P1, if I know P2, if I know rho m, if I know G, can I find H without knowing, without using this manometer? Without,
Yes, sir.
Yes, sir.
very nice, very nice. That is what I was asking. So what you have understood yourself, just try to understand the concept. It might be something which is unrelated to types of input. You might feel that it is unrelated, but I hope you will be understanding within the due course of time. So what I am trying to explain to you, even though I am not using, I am having no manometer, okay? And if I am very sure that if this value only depends upon rho m and G, and P1 and P2 is known, I can find H directly. Okay, so what does it mean? That output upon input is a constant. Just get it right. Since output upon input is a constant, okay, output upon input is a constant, we know already when output delta, I have already explained you in sensitivity. When output upon input is constant, what do we call it? We call the instrument to be a linear instrument. We call the instrument to be a linear instrument. I hope everyone is getting. So if this example was taken for which kind of input? This was taken for desired input. So what I'm trying to explain you is, if there is a desired input, okay, desired input means the input for which my instrument is desired. If the signal that I'm getting is only the signal for which the instrument is desired, such kind of input is called as desired input. Matlab, I am getting only the desired value. If I am getting only the desired value, okay, if I'm getting only the desired value, then I am very sure that my instrument is linear in nature, because I can find the value, of output based on the constants of the measuring instrument. I hope you're getting. Based on the constant of measuring instrument, I am able to find the value of my desired, whatever might be my output. Okay. So this was the basic thing that I wanted to explain. Now I'll get back to the definition. Just we will see the next slide. Just look at this. An input signal for which the instrument is desired to be sensitive is called as a desired input. Okay. This type of input will have what we are understanding. This type of input, one second. What we understood, this type of input are going to be linear in nature. Matlab, they will obey the law of sensitivity. Okay, they will be sensitive, and they will be how will they be sensitive? One second. They will be sensitive, but they will also be linear in nature. They will be linear in, one second, yeah. Give me a second. They will be sensitive, okay, but they will be sensitive in the range which is called as linear instrument. Okay, they will be linear in nature when it comes to reading, and the reading can be found out in terms of constant of the instrument, which is always constant. Okay, so this was the basic definition of linear sensitivity. I hope you understand. Sensitivity was what? It was change in output to change in input, and this was always constant for a given instrument. I hope you understood. Can we proceed? You'll get to know these topics in more detail once we proceed. Is it okay till now? Have you understood something about desired input? Everyone? Can anyone repeat desired input for me? What do you mean by desired input? Anas has understood, Arham has understood, Dakhani has understood. Can anyone repeat desired input for me? It is the signal for which? Can anyone? Hello. I've given you the access to unmute yourself. Can anyone let me know what you mean by desired input? This is very important if you proceed with the subject. This is not all about exams. It is more about the concept thing. When you go into industry, if you know all these things, if you know the theory, it is very easy to understand the practical aspect of the instrument. Since you already know how does the instrument behave, okay? Signal from the desired design instrument. No, I'm not getting your point. Anyone? Signal for which the instrument is
design.
Very nice, designed. Okay, is it a linear or non-linear kind of an instrument?
Linear.
Very nice, linear. So if it is linear, sensitivity will be constant or not constant?
Constant.
And can you tell me the value of sensitivity for this manometer, which was having system and atmospheric pressure? What was that value? 1 upon? 1 upon? Output upon input?
Rho mg.
Very
1
nice.
upon rho mg.
Okay, nice. Nice. We will get to the next type. Since we have covered desired, you will understand desired more once you get into the second topic. Now we are going to study interfering input. Okay. Now I'll just take the definition for you first. Since you have understood desired, you will be able to relate with this interfering input, for which the instrument is unintentionally sensitive. Okay. I am getting an input signal. Okay. And my instrument is unintentionally, matlab it doesn't want to get sensitive. Okay. For this input, my instrument does not want to get react, but it is getting reacted because it is unintentionally sensitive. It cannot oppose that input. Okay, I hope you're getting. If there is some input which is coming and वो बोल रहा है आन दे मुझे चलेगा, and वो क्या कर रहा है उसके साथ react कर रहा है, instrument मेरा क्या कर रहा है, react कर रहा है. तो for any kind of, I'll just annotate it for you here. For any kind of input signal for which my instrument is unintentionally sensitive, like I have written voltmeter. I hope all of you know why do we use voltmeter. We use it to measure the voltage. No, we use it to measure the voltage, or you can even say the potential difference in an electric field. Now, if suppose in that electric field there is a presence of magnet, okay, now what will happen, suppose this is my voltmeter, and if it wants to show a reading of 10 units, due to the presence of magnetic field, if it is showing a reading of 11 units, now this 10 to 11 change is due to which input? Can anyone let me know? You can reply via chat, via voice also. This 10 to 11, the change that is happening due to presence of magnetic field, this is
interfering
input. Now my instrument does not want to react, but it is reacting because it cannot help. Okay, so such kind of inputs where the instruments react unintentionally, those kinds of inputs are called as interfering input. To understand it more properly, what I'll do is I'll take an example again of that of a manometer. Just give me a second. We'll go to the manometer. Now, I hope you are seeing this manometer. One side is, I'll not show you the base of this manometer. I am just explaining you. One side is exposed to atmospheric pressure. Okay. Another side, you can see this is a system. So system pressure is there. And what do we basically assume? That the system pressure is greater than atmospheric pressure. Okay. Now, let this atmospheric pressure be P1. Let this system pressure be P2. Now, we know that P2 is greater than P1. If P2 minus P1, if we are putting, we know that P2 is greater than P1. Now, I will again clarify. If P2 minus P1, then H will be positive for us. Okay. And if we by mistaken, if we put it mistakenly, P1 minus P2, we have to consider H to be negative. Since we already know that P1 and P2 is greater than P1. Okay. So what I'll do for you is, I'll just show you what do you mean by interfering input. Just look at this setup. I think someone has asked something in the chat box. Sir, any instrument which contains magnet can be said as interfering. No, it depends. If my suppose this is my instrument and this is used for a magnetic field, matlab the input is a magnetic field only. So this won't be considered as an interfering input. But if some external magnetic field also arises in the system, which was not specifically designed for this system, and the system is responding to the external magnetic field also, then such kind of input is called as interfering input, for which I was not designing my system. Suppose there are two magnetic fields. I designed it for magnetic field 1. I had not designed it for magnetic field 2. Suppose there is a stray magnetic field which is coming into the system and which is making the system's output change. Matlab, due to some external input which was sensitive to the instrument has reacted to that input also, and that has changed my output. So such kind of input is called as interfering input. Okay, Dakhani Arsalan. Okay, got it. Okay, thank you. Now we'll just look at this interfering input in this way. Just look at this. What I have done, I'm just showing you a system. This is not moving. Actually, I would like to explain. This is a roller and this is on a base. I hope you are able to see this is a base. You can see this is my roller support and this will roll. Actually, this is not rolling. Okay, this is at stationary position. Now suppose, where is my, yeah. What I'm saying, suppose this, my system is moving with some acceleration. Just get it straight. Suppose my system is moving with some acceleration. Now, if my system is moving, automatically this roller will also move. Okay. Now, if this moves due to acceleration, now we know that acceleration has an impact. Okay. Now, this acceleration will act as an interfering input. Okay. What it is doing, I will just explain you. What was the initial condition? What we are assuming, this was at a higher level due to the pressure at this side to be more. Now, due to this interfering input, suppose what happened, this acceleration has changed the condition. How has it changed the condition? Due to the presence of this acceleration, this side has gone down and this side has risen up. Suppose, okay. Now what has happened? This might not happen. What I will like to explain to you, I like to explain to you in the different manner. Suppose this is my one side, this is my another side. When my system was not accelerating, when there was no acceleration, matlab no interfering input, no interfering input. Okay, so I was getting a reading. Where is my cursor? I was getting a reading. Suppose I was getting a reading of H1. What was the reading? H1. Now suppose my system is accelerating. Okay, so if my system is accelerating, there is interfering input. Now if there is an interfering input due to system acceleration, I will just do one thing. I'll just take another color. Suppose this side has gone, it might happen in either way. This side has gone, one second, yaar. This side has gone to a lower level. I'm just assuming. And if this has gone to a lower level, suppose there is a difference in pressure. Due to this acceleration, the height that I am getting right now, suppose this height is H2. Now we know that instrument was to measure H1 value. Okay, now the instrument is measuring which value? H2 value. Now we know that H1 is without interfering input, right? With a no interfering input. And when there is interfering input, I am getting some another value of the pressure difference, because we already know, we have already covered that delta P, right, is nothing but rho m into G into H. Now this H is getting manipulated due to the presence of acceleration. Such kind of system are called as interfering input, which are changing the value, which are changing my output, matlab, which are actually changing my input, and due to change in input, there is a change in my output. Matlab, initially the input was only P1 and P2. Now the input is also that of the acceleration. And if due to acceleration, this H is changing from its value from, one second, if this H is changing, it kahan par hai cursor? If this H is changing its value from H1 to H2, such kind of input is called as interfering input. Before completing it, what I'd like to explain to you, I'll just like to ask you something. Initially, what did we see? Initially we saw something. I will just put something. P1 minus P2 or P2 minus P1, whatever it is, rho m into G into H. And what did we saw? We saw output, which was H, input, which was delta P, right, was equal to 1 upon rho m into G. Okay, this was for which instrument? This was for desired input, okay, which were having only desired kind of input. Now just look at this thing. I am telling you about interfering input, okay? When I am telling about interfering input, what is happening in interfering input? Again, there is an output. What is the output that we are expecting? H, okay? And there is an input. The input that we already know is P, delta P, right? But we know delta P is also having some kind of acceleration, right? So now this value will not be a constant of the instrument. This won't be a constant of the instrument. Why? Because now I am not getting only H1. Initially what I was saying, this was only H1. Now what I am getting is H2, which might be greater, which might be lower, it might be anything. It depends upon what is my acceleration, right? It depends upon how does the acceleration contribute to the change in input. Okay, if my acceleration is contributing to some kind of change in input, then I am pretty sure, what I am sure? I am pretty sure that this value will not be equal to 1 upon rho m into G, because earlier it was used to be the constant of the instrument. Now it won't be equal to the constant of the instrument due to the presence of this external signal, which is acceleration. Is everyone understanding what I am trying to explain? Just let me know. You can put it in the chat also. Is everyone understanding what I'm trying to explain? Now H2 will not depend upon only the instrument constant. It will also depend upon something which is acceleration, not a linear instrument. Very nice. Now this instrument has become non-linear instrument. Why it has become non-linear instrument? due to presence of acceleration which is contributing. I'm just taking factor acceleration as an input signal which is contributing to the input signal and which is affecting actually the output signal. Okay, such kind of instruments are called as non-linear instrument. Okay, so if I get into detail, one more thing I would like to add, very important thing. K, sensitivity was output upon input, right? Sensitivity is change in output, matlab change in response, initial final response minus initial response, final input minus initial input, whatever is the thing, that is called as sensitivity. If this is constant, one second, if this is constant, this is called as linear instrument. Okay, and that thing is called as sensitivity. Just get it right. If the instrument is having output upon input as constant, that such instrument is called as linear instrument, and this is called as sensitivity. What do we call it as? Sensitivity. Just try to understand what I'm trying to explain. Now, if the instrument is non-linear, what I'm saying? Non-linear. Just try to give me a word for this. If the instrument was linear, the instrument was sensitive. So if the instrument is non-linear, can we call it as non-sensitive? Reply with your voice. If the instrument is linear, we call it
No,
as.
sir.
So if it is non-linear, we will directly write non-sensitive.
No, sir.
I hope everything
Every
is clear.
instrument have sensitivity.
So this instrument is sensitive and this instrument is sensitive to some outside signal also, which was acceleration. So if just try to understand, there also I am getting output and here also I am getting input. But what is the thing? This is not linear. This is non-linear. I hope you're getting. So whenever there is an output to input response which is non-linear in nature, try to understand what I'm trying to say. Whenever there is output to input response which is linear in nature, that is denoted by K, which is called as sensitivity of the instrument. But whenever there is output to input response of the instrument which is non-linear in nature, then such kind of output to input are not called as sensitivity or non-sensitivity. This is called as transfer function. What do we call it as? Transfer function. I hope you're getting. Transfer function is used to correlate between output and input of a non-linear instrument. Can anyone repeat it for me? Transfer function, rather than using the term sensitivity, what is the term that we use? Transfer function is used to, what I said, can you repeat it? Transfer function is used to correlate the response. Can anyone repeat? Transfer function is used to correlate the response signal, is used to correlate between the response signal, and what? Input signal of a non-linear instrument. Can anyone repeat it for me? I have written it in the screen. Can anyone repeat it for me? Transfer function is used to correlate the response between the transfer function is
Transfer function is used to correlate between the response signal input of a non-linear instrument.
represented by K.
Sorry.
Don't
Transfer function.
We represent it by a term which is called as G. What do we call it as? We represent it by a function which is called as G, transfer function. Okay, you will use this function when you go to control system, when you go to 4th, 5th and 6th module electronic instruments, you will use this kind of function, transfer function. Okay, so the transfer function is basically used to correlate between the response as well as the input, or you can say it is used to correlate between the output and input of a non-linear instrument. Now I would like to ask anyone, I need answers. I need answers. Yeah, this is not going to help. Asghar. Yes, Asghar. Please unmute yourself. Asghar. Hello, Asghar. Are you sleeping? We don't have much time. Asghar. Okay. I would like to hear from you. What is the difference between K and G? Asghar, we have only 7 minutes. We need to finish with the third part also. What is the difference between K and G, Asghar? Kunal, can you help me? Kunal,
Hello, sir.
the difference between K and G? K and G. Kunal, can you help me out? I'm expecting you people to respond. Let it be. I'm fed up. Thank you. Can anyone reply in the chat? We need to finish, but I need some response from you people. What is the difference between K and G?
K is a sensitivity is correlate between response signal and input signal of linear instrument.
Okay. And G?
And G is a transfer function is correlate between response signal and input signal of non-linear instrument.
Very nice. Thank you, Shoaib. Thank you so much. So we will proceed with this. Now we will take the third part, modifying input. Now this is something which is correlated to the interfering input only, but this is in addition to that something interfering is like instrument cannot oppose it. Okay. And modifying input, you can see it here. We have already mentioned. I will just try to explain it as fast as possible so that we complete it within time. So it changes the input output relationship. So this is also a part of interfering input. Now what I have explained you interfering input, that was also changing the relation between input output. This is also changing, but we will try to see it in a different manner. I'll just explain you with an example, strain gauge and tilted manometer. I'll explain you with a tilted manometer. I could have explained you with strain gauge also, but I'll take the example of manometer only. So just look at this diagram. Now you can see this diagram. Now what you can see here is there is an input. Suppose karo this is a pressure P1. This is connected to something or not connected, or there is some difference in pressure. P1 is something different and P2 is something different. Okay. So what I'm putting here is P2. Okay. Now we know that this is tilted. This is tilted at an angle theta. If this angle is theta, we already know this angle will also be theta. Earlier, the gravitational force was in downward direction. Okay. And it was not contributing to any kind of acceleration. I hope you're getting. Earlier, we used to accelerate the system. I hope you're getting. Earlier, what we were doing, we were accelerating the system, right? Here, when we were accelerating, this gravitational force was not at all contributing. Okay. There was some kind of external signal, which was acceleration. Yes. Now this signal here, if you see, this is my M into G, right? And now I know that this will be mg, since that angle is cos theta, this will be mg cos theta, right? And this angle will be, this value will be mg sin theta. Now this is different as compared to interfering input. This is modifying input. When we are saying it as modifying input, something which is there in the system, not outside the system. Get it right. Something which is there in the measuring instrument, not I cannot say system, something which is there in the measuring instrument. Get it right. Earlier it was there in the system. That was not the measuring system. Measuring system was my manometer. Something which is there in my measuring system or measuring instrument. I hope you're getting. Now my measuring instrument here is manometer. Now if something is there in my measuring instrument which is inherently changing the input and output relation, inherently matlab which is embedded into the system, by its nature it is changing the input output relation, such kind of inputs are called as modifying input. How is it changing? Now this M into G, earlier this was not contributing to any kind of change, matlab in pressure difference. If this was P1, this was P2, this m into g was not contributing to anything. Now suppose if this is the level, okay, actual level, now due to this m into g, the pressure force, you can see this force, the inertia force, m into g into sine theta, what it will do, it will change its value. It might happen the pressure in this side might get increased. Okay, so if the pressure in this side gets increased, its level will go down and its level will rise. I hope you're getting. So what I'm getting here is there is a change. Matlab earlier it used to be, earlier what was the value? Suppose earlier the value was h1, right? Now what I'm getting the value is h2. I hope you're able to see this. Okay, now the value is what? h2, and this is due to the measuring instruments internal characteristics changing. Measuring instruments input internal characteristics are changing. Okay, such kind of instruments are called as modifying input. Okay, this is not given by the system, this is not given by some other signal, this is due to the placement of the instrument. Suppose I have tilted it, now this tilt has given what? This has given some kind of inertia into the system, some kind of force into the system, and that force is again contributing to what? That force is contributing to my output signal. I hope you're getting. Reply it in the chat box if you're getting. Now what I'm saying, H2 earlier was what was the value earlier? If you're getting, just let me know. There is some inherent change. If there is some inherent change, very nice, Tabish. Thank you so much for responding. If there is some inherent change into the property or into the measuring system, then that is called as modifying. So I would like to explain all the three systems together to you. First was desired input. Desired input was represented by K, which was given by output. I'll just put it, change in output upon change in input. For us, it was output was H, change in input was delta P, which was equal to 1 upon, I'll just put my screen, give me a second. Yeah. So this was 1 upon rho m into G, right? Now, for interfering input, what did I got? For interfering input, I got some function which is called as transfer function, where output upon input, which is again h upon rho p plus a, right? This was not equal to 1 upon rho m into G. That will be equal to some other value, which is called as transfer function, because this is non-linear in nature. This is non-linear instrument, and this non-linear instrument is due to presence of external signal, right? This is not inherent sensitivity, this is external sensitivity of the instrument. Now what I'm saying about modifying input, it looks similar. Output upon input, it will look similar to you. There is some output, there is some input, and one more thing is h upon, now this will change. What I have to put here is mg. For our case, it was mg sine theta which was contributing. It might be contributing in a positive manner, negative manner, we don't know. We can even put plus or minus here, and this will again not be equal to 1 upon rho m into G. Now this change, modifying input change, what do we call it as? This is changing the inherent input and output characteristics of the instrument. It is changing the inherent input and output characteristics of the instrument. Can anyone repeat it for me? What does modifying input do? Repeat it fast. It changes the, can anyone repeat it, please?
Input signal will change the input output relation.
Inherent, inbuilt, inherent input and output characteristics of the instrument. This is not an external signal. This is due to the instrument's care. You can say it might be due to calibration. It might be due to some error. It might be the way you place the instrument. There are many things that you will get to learn it. As you proceed, you will get to learn it more and more about modifying input. Okay. Now, before completing the lecture, I need to again explain you something so that we can complete all this thing together. I have just shown you a block diagram. What I'll do is, this is important. Since I need to show this, I'll just do one thing. Just give me a second. Give me a second. Don't rush to for me to complete the lecture. Now, what I am doing is, this is my input. 1 second. We know there are 3 types of input. I hope everyone knows there are 3 types of input. What are my 3 types of input? 3 types. One is desired. Another is interfering, right? And another is modifying. I hope everyone is understanding. Okay, now what I'll do is, I will put here, suppose I am putting interfering here. I'm just showing this part to be an interfering input. Okay, now I am showing this part. Where is my cursor? Yeah, just give me a second so that I complete this lecture. This is suppose my desired input. Okay, now let this be my modifying input. Why I am putting modifying input, you'll get to know in the center. This is my modifying input. Now I know that modifying input is the inherent sensitivity of the instrument. It is the inherent characteristics, input characteristics of the instrument. Okay, this is not something which is given to the system. This is into the system. So if there is something which is into the system, let this be the control. We know that this will have 2 transfer function. What I'm trying to explain here is, this is transfer function. We know for this it will be sensitivity, because this is desired input. But if I get some kind of modifying input from the system, suppose that my system is designed for desired input, but if I'm getting some modifying input also into the system, see, this is my one part. Okay, if you can see, this is having some modifying input right now. So this is my modifying signal. This is my modifying signal. Suppose if my modifying signal is going to my desired input, it will change my K. It will change my K to G, and it will now be a function of modifying as well as desired. Now this will change into a transfer function, which will be a transfer function of modifying as well as desired. Okay, now what I'm saying, modifying input was having 2 functions. One function which was transfer function called as GM. Now this GM, if it goes to desired, it will change its value to GM of D, right? And this was already G. Why it is already G? Because we know that this is not for linear instrument. This is for interfering input, is always for non-linear instrument. Modifying will also make the instrument non-linear, which will make the instrument's input characteristics non-linear. I hope you're getting, okay? So what I'm saying, this was already having interference, and modifying is coming from this side. I hope you're able to see modifying characteristics. So if some modifying characteristic is coming into the system, which was having interfering input, this will change GM into I, right? What I'll get is GM into I. So now my system, suppose my system was having 2 kinds of signal. It was having desired signal as well as modifying signal as well as interfering signal. It was having everything. Now modified signal has given its value to interference as well as to desired. I hope you're getting. It has given its value to interference as well as it has given its value to desired. Now I will get actually 2 main signals. This is my one signal GMI, which is transfer function of modifying as well as interfering, and GMD, which is transfer function of modifying as well as desired. Now what will happen? This both signal will go to a summation block where my signal will add. Don't worry about summation block, you will understand it later. This will go to summation block. Now both of the type of signal, there were 3 types of signal. Modified has given its characteristics to interference as well as desired. Now there are 2 signals that are remaining. One is interfering, one is desired, that will be there in the output of the system. Okay, what I am saying, this both signals are getting summed up here. So what I'll get into my output will be GMI, right? And my output will be GMD. I hope everyone understood. My output will be a case of GMI plus GMD. Is everyone getting? Sorry. Is everyone getting? Put reply with your voice.
Yes, sir.
Are you getting what I'm trying to explain with this summation block? This is very important for you to understand. Now this G is what? G is what? What was the basic formula of G? Ratio of G was ratio of
Output and
upon
input.
Very nice. So one will be ratio of output and input with respect to interference and modifying. One will be the ratio of output to input with respect to desired and modifying.
desired.
I hope you're getting. See, last thing. This is due to, this will be output to input of modifying and interfering, right? And this transfer function will be my output to input of modified and desired. You will get to know it clearly if once we go into detail. What I'm trying to explain you is the types of input. So what are the basic three types of input? One is desired input, one is modifying input, one is interfering input. Just as I know I have taken it long, but I just need to, this is more than enough. Okay. Okay. Is there any doubt that you want to ask?
So there was